Hello everyone. In this video we'll see binary trees pre-order traversal. Pre-order traversal is one of the three methods traversals: pre-order, in-order and post-order. Here I have one full perfect binary tree structure, and I have the node definition as data, and right and left pointers are there associated with this binary node. Okay, what's this pre-order traversal is? These orders or traversals are on the basis of data. Where the data is, that's what's decide what kind of traversal it is. So if this data comes at front, this is called pre-order traversal. If it is relies in middle of this left and right, then it is called in order. Then if it is at the end of this left and right, this is called post-order traversal. Okay, this where this data is, that's what actually matters of the this traversal. It's all depends on where this data is. Okay, here I have a code snippet written in this element called pre-order. It will take one node, and if the node is null, I'll return. So node is null, there nothing to do with this node. And then first I'll print the content. This traversal is all of the printing the content. So first I'll print. That's what the pre is. Pre means that priorly we are accessing first data. If it is accessing at the middle, then it is in order. At the end, it is post order. Okay. Now once I access this data, I'll go for left. What's the content in the left? Then I'll print it. Go for the left, and that again it triggers. It is a recursion based algorithm, and then it will triggers the right. But this is not possible. This right will come at front and left. No, this is the only possible. Always left should come at first, and then only the right should come. Okay, this is some of the properties associated with this binary trees. Okay, first we'll check the node is null or not. If it is null, we'll return, and then first we'll print the content, and then we'll travel at the left side, and then we'll travel at the right side. Okay, here I have a three complete binary trees. Three binary trees are available. In these three examples, we'll do the pre-order traversal, and we'll see the output here, and then we'll switch back to Visual Studio, and we'll write the actual coding for that. Okay, this is a full set of binary tree. Here you have the nearly 4 and 7 nodes are there. Okay, how do we do this pre-order traversal? First, I have to check this node is null. If it is null, return. Here I am having the root node given, so it is not null, so I can continue. First, here it is printing. First is print. That's the pre-order is. So it's prior, it's coming. So first I have to print this 10, and then only I have to go to the left or right. Okay, I'll go to the left. Then I'll print this 20, and I'll go to the left, and then go this 40 is there, then here nothing is there. First print it, and then I'll go to left and right. Here I don't have anything, so my this line will triggers and it will return. Okay, now in the stack it will be like 20 is there, and then it goes to 50, so 50 will be printed, and then it is checked for right and left, nothing is there, so it will come out. And then here it will goes to 30, so it will print, and then it will goes to the left, and then it will print 60, nothing is there, so it will come out. And then it goes to 70, print, and then nothing is there, it will come out. So what's my exact answer will be is, first I have 10, and then I'll have 20, and then 40, and then 50, and then 30, and then 60, and then 70. Okay, hope you understood with this, and I can explain the same thing with the help of a stack. Here all are recursion calls because we are going to do the same operation in the left or right side. That's the reason we have to use this recursion. There are other ways also you can use, like queues, in order to find out what the in order pre-order traversal is. Okay, Now this one, when to how you are stopping the condition in the recursion is, you are now when this node is null you are printing here. We didn't trigger anything further because these nodes are nulls, so that's the reason we return to the actual program. Okay, now the help of a stack, will how do we understand this one is, the actual recursion itself is a stack. So internally the program how it maintains is with the help of a program stack built in with the computer memory. So it's must you understood this with the help of stack. Now we'll solve this problem with the help of a stack. So internally the computer will be represent these kind of recursion calls in terms of stack. So you no need to code for stack, and these recursion calls, the program stack itself, the compiler itself, it will manage. So we, in this example itself, we'll use a stack, and then we'll see whether the same output for this pre-order traversal output is exactly matching or not. Okay, initially I've given this node 10. So if it is null, we have to exit. First we print the data, and we have to travel left side and then right side. Okay, now we have this 10. So what I do is, I'll first print it and then I'll add it to the stack. First I have 10, so I have 10. Okay, now what I do is, I have to travel this left side. So what I have is, first I print it and add it to the stack. So printing means here you can write 20 and then here add it to the stack. The next is, I have to go to the left side only. So 40, I have print it and add it to the stack. So here 40 and add it to the stack. And next I am going to the same left because it's triggering at the left call. So here when it comes, it don't have anything, so right or left nothing is there, so I can take it out. So take it out. Okay, for this 20 I finished this left side call. I have right side call. So what I do is, I'll print this 50 and then add it to the stack. Okay, now I have 50 and I don't have any right or left, so what I do is, I'll delete it. Okay, now 20 also right and left is done, so delete it. So next 10 is there. I finished this left side, I have this pending right side. So what I do is, I have 30. So what I do is, I have to print so 30 and add it to the stack. Then I'll check for left, is it anything is there? Yes, it's there, so print it and then add it to the stack. For 60 I'm looking if right or left is there. No, it's not there, so delete it. And then I have to travel at the right side. So 70, what I'm doing is, I'm printing and here 70, and 70 don't have any right or left, so delete it. This 30 also right and left is over, so delete it. And this 10 also right and left is over, delete it. So we got the output as exactly same how we use these recursive calls. So it's nothing but the recursion and other stack trace stack option which gives me the same result. Okay, the same thing we'll write for this one also, this two trees. So I have 10. First I'll print it and then I'll go 20, I'll print it, I'll 40, I'll print it, then I'll go 30 and 60. This is the answer. So the answer will be 10, 20, 40 and 30 and 60. Okay, in this example, first I have 10, I have 20, 30, 50 and then I'll go left and right. So 10, 20, 30, 50 and 60, 70. This will be my answer. So 10, 20, 30, 50, 60, 70. Okay, hope you understood this the way how we do this pre-order traversal in these examples. Now we'll quickly jump to the Visual Studio Code, and we'll see how to write the programming for this. So now we are in Visual Studio Code, and here I have some basic setup. I have the necessary importings, and I have class called node, and I have data node right and left 2 pointers, and I have constructor with the parameter of this data, and initialized to this right and left to null. In the actual int main program, I have this 3 trees, 1, 2, and this is third one. But namely, it is this 3 trees, 1, 2, and this tree, third tree. First, second, third. These 3 trees are I've written in the line number 4, 19, 29, and 37 onwards. Okay, now we'll write the actual program. What I do is void pre-order. I need a root, so root. If this root is null, then I have to return. Then first I have to print what's the content. So root data, then I have to start pre-order of roots left, and then pre-order of roots right. Now I uncomment all these nodes. I have node M, N, and Y. Okay, now our code is ready. If it is null, I'm returning. First I print the data, and I'll trigger left side and right side, and here I make the calls for each pre-order traversal. Now format the document and run. Okay, I have this output. I'll check it against my manual operations. 10, 20, 40, 50, 10, 20, 40, 50, 30, 60, 70, 30, 60, 70. Okay, now 10, 20, 40, 30, 60, 10, 20, 40, 30, 60. Okay, next 10, 20, 30, 50, 10, 20, 30, 50, 60, 70. Here also the same output. Okay, all our test cases are passing. Hope you understood this problem and solution. Okay, and thank you for watching this video, and we'll meet in the next video.